this video, I'm going to show you how to find the exact values of trig ratios. So the usual trig ratios that we do in grade 11 are sine, cosine, and tangent. However, we're going to step up a little bit and go to the reciprocal trig ratios, which is cosecant, secant, and cotangent. And I'll show you how to do that later, but we're going to start easy with finding cosine 150. Before we talk about cosine 150, let's talk about what's exact values and why we call these two triangles the special angle triangles. So in the special angle triangles, let's say they ask me to find sine 60. Of course, you could go into your calculator and write sine 60, and it will give you a number with decimals. When you get that in your calculator, that's not exact values. So when they say exact values, they want you to refer to the two special angle triangles. And sine 60 here, going back to SOHCAHTOA, sine is opposite divided by hypotenuse, and cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if I'm doing sine 60, I go there, sine is opposite, which is this side here, that's √3 over the hypotenuse. It's always opposite to the right angle, which is 2. So √3 over 2. Yeah. Now, how about if they ask me to do tan 45, and they want exact values? So tan 45 degrees, you go to the 45, one of these, because both of them are 45. Tan is opposite, which is that's opposite, over adjacent, which is this one. So it's just going to be 1 over 1, which equals 1. Okay. So just know that adjacent means besides, and it's not the hypotenuse, because the hypotenuse is always besides the 45. But because it's the hypotenuse, we cannot call it adjacent, because the hypotenuse is always opposite to the right angle. See? All right. Now let's go to the cos of 150. So you know how we measure angles from 0, and we go counterclockwise. So we go in this way, and we're going to go all the way to 150. Okay. So a lot of students ask me, how accurate do I have to be? You don't have to be really accurate, as long as you're in the second quadrant right here, because 150 happens to be in the second quadrant. It's quadrant 4 right there. So you're supposed to be right here, and then you make a triangle right there. Now, if this is 150, what's remaining to get to 180 here is 30 degrees. So this becomes 30, and this is 60, and that's 90. So basically, you draw your triangle right there. So this is your reference triangle, which is the 30, 60, and 90, according to the 150 here. So now if I'm doing cosine 150, I'm going to work from here. Okay, instead of 150, I'm going to work from the reference angle, which is the 30 degrees. And that's why we call it reference angle. It refers to the 150. And I have to label this triangle according to how it's labeled right here. So if we look at the 30 here, opposite to 30 is 1. So opposite to 30 is right here. That's 1. The hypotenuse is 2. And the adjacent is √3. The only thing that's missing right now is this is negative √3, because this is the negative part of the x-axis, and that's why this has to be negative √3. So cosine 150 will be adjacent, which is this one. So negative √3 over 2. Adjacent over hypotenuse. Okay. So how about if they ask me to find the tangent of 240? So 240, again, we measure from the 0, and we go this way right here. 240 happens to be between 180 and 270. So my reference angle, where I'm going to draw my reference triangle, is going to be in this quadrant, quadrant number 3. So from here to there is 240 degrees. Now, of course, we have to find out what the reference angle is here, because we know this is 90 right there. So the reference angle, to find out what that is, you just go all the way to 240 and then take away the 180. So 240 minus 180 gives me 60 degrees. So my reference angle here is 60 degrees. If this is 60, then this is 30 degrees. Now we go to the 60/30 again. Opposite to 60 is √3. So opposite to 60 is this way. So that's √3. And you remember I said this part of the y-axis is negative, so this has to be negative. The hypotenuse is always positive. Okay, just remember that the hypotenuse is always positive. So the adjacent side to 60 is the 1. And also here is going to be -1 because that portion of the x-axis is negative. Now tangent is opposite over adjacent. So that's going to be negative √3 over -1. That's the opposite. And that's the adjacent right here. So negative √3 over -1. And you should simplify that. How about sine 315 degrees? So again, the 315, you want to draw this, and 315 happens to be between, of course, 0, 90, 180, 270, all the way around is 360. So when you do a full revolution, there is going to be 360 degrees. So therefore, the 315 should be between the 270 and 360. So 215 should happen to be somewhere in here. So what I do, I draw my triangle right there, my reference triangle. And if this is 315 right here, then the reference angle right here would be, you go all the way to 360 and take away the 315, which gives me 45 degrees. And if this is 45 and this is 90, then this must be the 45. Because when we say find the exact values, it has to be from these two triangles as far as the 30, 60, and 45 are concerned. Okay. So now if it's 45, 45, we know this is 1, this is 1, this is √2. The only thing I'm missing is this has to be -1 because we said the y-axis here is negative. Okay. So let me kind of use this green so we know that we're dealing with this. And the sine is opposite, which is -1. So that's the opposite right here, over the hypotenuse, which is √2. Okay, so that should be the answer. But some teachers would like you to rationalize the denominator by multiplying top and bottom by √2 over √2. And that should give you -√2 over 2. So you could you'll see some of the answers expressed as -1 over √2, and some of the answers will be expressed in rationalized form, which is -√2 over 2. All right. So how about now we're dealing with negative angles. So we want to find cos of -225. Negative angles just mean instead of measuring counterclockwise, you measure clockwise. So now you start counting as this is -90, -180. So -215 should be somewhere in here. And you make your triangle right there. Yeah. So this is your -225. So if you look at it as just 225 there, all the way to here is 225 minus 180, it will give you a reference angle of 45 degrees. So the reference angle, you just write it in exact, as positive. So the reference angle is positive, okay? So the only thing with -225, you're just measuring clockwise. And that's when you measure clockwise, the angle is negative. So you could always look at this as -90, -180, -270, and then all the way around would be -360. And then the rest is just you label, this is 1, this is going to be -1 because the x-axis here is negative, and this is √2 right there. So cosine -225 will be adjacent, which is to the reference angle, which is right here, which is this right here, -1 over √2, which is the hypotenuse. And again, you could rationalize the denominator by multiplying by √2 over √2, and then your final answer could be -√2 over 2 if you want to rationalize the denominator. So now let's go and look at finding the exact values when the angle is given to us in radians measure. So if the angles in radians measure, one thing you could do is go and convert the angle from radians to degrees by multiplying it by 180 over pi. So I could take this 3 pi over 4 and multiply it by 180 over pi. That's 180 right there. Now the pi's would cancel. Four reduces to 1 and 180 to 45. Now 3 times 45 is 135. So we could switch this to tan 135, and then we go back to just dealing with degree mode again, or degree measure in angles, and tan 135. So we draw the 135 first. So 135 happens to be in the second quadrant because it's between 90 and 180. Make the triangle 90-degree angle triangle, my reference triangle. As we said, this is 135 degrees here. So the reference angle to 135, you go 180, take away the 135, and it gives you 45 degrees. So this is 45, this is 45. And therefore, this will be root 2 according to this triangle. This is 1, and this is -1 because the x-axis here is negative. So tan 135, its opposite, which is this one here, over the adjacent, which is that one. So 1 over -1, which gives me -1. So that's how you do tan 3 pi over 4. So when it's radians measure, you just convert it to degrees and go with that. So pi over 3, the pi, you know, all the way to here is pi, and here 360 is 2 pi. The 90 is pi over 2 in the radians measure in the unit circle, and this is 3 pi over 2, the 270. Now, if pi is like the 180, so pi is 180, 180 divided by 3 is 60. Sine 60 would be opposite over hypotenuse, so the same thing there. Pi over 4, pi is the 180, so 180 divided by 4 is 45. Tan 45 is 1 over 1 and gives me 1. Yeah, so we're gonna now just show you how to do reciprocal functions with exact values. So here's the reciprocal functions, secant, cotangent here. But just let's go over what cosecant means. For some grade 11s that they want to learn something new, cosecant is the reciprocal function of sine. So cosecant basically is 1 over sine. This is called secant. Secant is 1 over cosine. And this is called cotangent. Cotangent is 1 over tan. So the way you should look at this, if you're doing this question right here and you're doing secant 2 tan, the first thing we're going to do is draw the 2 tan. And the 2 tan will happen to be right here. We draw our triangle, bring a vertical right there. That's 90. That's 2 tan right there. The reference angle, when it's 2 tan, you go all the way to 2 tan and take away the 180. It gives you 30 degrees as your reference angle, because 2 tan minus 180 gives me 30. So if that's 30, then this is 60 right here, degrees. Opposite to 30 is 1, except it's going to be negative here. And adjacent or to 30 or opposite to 60 is root 3. And also here it's going to be negative, because the x-axis here is negative. And the hypotenuse, as I said, is always positive. So secant, if it's the reciprocal of cos, and cos is adjacent over hypotenuse, then the secant will be going this way, hypotenuse over adjacent instead. So it will be 2 over negative root 3, because as I said, the secant is the reciprocal of cos. If cos is adjacent over hypotenuse, then the reciprocal will be hypotenuse over adjacent. So it will be 2 over negative root 3. If I want to rationalize the denominator, I just multiply this by root 3 and this by root 3. And my final answer would be negative 2 root 3 over 3. It's always better to write the negative on top. Okay. It looks better than having it on the bottom. So this is the answer for secant 2 tan. How about cotangent 5 pi over 4? So as I said earlier, the first thing you want to do when we're dealing with radians, take the 5 pi over 4 and convert it to degrees. Okay, So if we're gonna convert radians to degrees, as I said, we multiply by 180 over pi. So I'm just gonna take that right here, take the 5 pi over 4, multiplied by 180 over pi. So the pi's would cancel. The 4 cancels and the 45 become, the 180 becomes 45. And 5 times 45 is 225. So this basically becomes cotangent of 225 degrees. Okay. Now let me just do some erasing here. I'm just gonna erase this because we finished with this already. So therefore we're doing cotangent 225. 225 happens to be here as well. So that's where the 225 is. We draw our triangle from 0 all the way to here is 225 degrees. My reference angle here would be 45 because 225 minus 180 is 45. So this is 45 as well. So this will be -1, and this will be -1, and this will be 2. So cotangent 225, which is representing the 5 pi over 4, will be opposite over adjacent. So -1 over -1, which gives me +1. So in this question here, I hope I said it's adjacent over opposite because the cotangent is adjacent over opposite, even if I said opposite over adjacent, it doesn't make a difference because both of them are -1s and you'll still get the right answer. Okay. And that's it for finding exact values. We went through degree, angles, and then we went through radians, which is simply just change them to degrees and keep on dealing with degrees instead. There's another way of doing it, but I think this is the easiest, or from my experience, a lot of students like to convert them to degrees and deal with degrees since they learned degrees in grade 11 and now in grade 12, they're doing it again. And then the reciprocal functions, you have to know the cosecant, secant, cotangent, and what they are reciprocal of. So the cosecant is 1 over sine, secant is 1 over cos, cotangent is 1 over tan. And then in that case, you just go to secant, it will be a hypotenuse over adjacent instead. The cotangent will be adjacent over opposite instead. If you found this video helpful, please like, share with others who will benefit, and subscribe to the channel. Your support goes a long way. Just know that math videos uploaded every week. Check out our other videos and browse our playlists for more helpful math videos. As always, thanks for watching. Till next time, bye-bye.